Our subject is trigonometry. And so we're going to talk a little bit about some of the introductory ideas, some of the basic terminology, the basic notation, and use that as a foundation that we're going to build on to do the rest of our work this semester in trigonometry. Trigonometry, the word itself comes from actually three Greek words, prefixes, roots, tri, corresponding to the Greek for three, gon, corresponding to the Greek word for angle, and meter, metri, comes from meter, roughly corresponding to the Greek idea of measure. And so trigonometry is about measuring triangles. Trigonometry is about measuring triangles. There's a lot more to it than that, but the very core basic idea is we have triangles and we measure them. Now, to get from here to there is going to take a little bit of some work, and that's going to occupy, well, the good part of the semester. But that's eventually the goal, to be able to measure triangles and find the values of the angles and the lengths of a triangle. All that goes into what we're studying with triangle, and then there's much more that goes into trigonometry as well. So we're going to start with some basic terminology that I hope you recall from your glory days in geometry. We have a line. Now, typically, one way to express a line is if we have 2 points, then we can talk about the line that contains them, or the line that passes between them, or the line that passes through them. And so we can talk about this line. Now, we understand that these are idealized structures. We understand that even though I draw this with some thickness that allows you to see it with the physical chalk on the physical board, we understand that ideally the thickness of this line, the width of this line, is actually 0. The notation typically that we use for a line is in this format. One of the notations is AB, and then we make this little double arrow across the top. This is line AB. This is the line that passes through the points AB. The order for this is irrelevant. And so if we write BA, that is, in most circumstances, there are some exceptions, but in most circumstances that is considered to be the same line. Now, if you do not want to include the part that extends beyond the points between A and B, then we have what's called a segment. So there's a difference between a segment and a line. A line contains the segment. A segment is a portion of the entire line. And so if we have point A and point B, here's A, here's B, and I'm writing my A to the left and B to the right. There's nothing that requires that. The orientation is irrelevant. We could have B here. We could have A here. This is a segment. So we could have B extending to A. And this would then be written as segment BA. Notice that there are no little arrows here. Or this is considered to be the same as segment AB. Segment BA, segment AB is the same. Line AB, line BA is considered the same. But then we have the notion of array. And array, there's a little bit more going on here. Array, if we take one point, let's call this one A, and another point B, and extend from A through B, but continuing on only on one side. So we say A is the end point of the ray, B is a point that lies on the ray, so this is a ray, and then the notation we make is only one of the arrows. And in this case here, these are considered the same. These are considered the same. However, these are not the same. Ray AB and ray BA are not the same thing. Because when you write the notation for a ray, the point that falls under, see this piece that does not have the arrow? This must be the end point. And we say it emanates. So the ray emanates from the endpoint A and passes through B. And so in order to have this, this would correspond to, let's do it in a different color. If I had a ray that starts at B and passes through A, this is ray BA. But the white I have here is ray AB. So it matters the sequencing when you're talking about a ray. For a segment or a line, it doesn't matter either way. All right, so with that, and again, that is, I really, really hope, that is a review of some basic geometry that you've encountered before. The big deal today is to talk about what we mean by an angle. If trigonometry measures triangles, so triangles have three of them. They have three angles. And so an angle is of fundamental importance with the work we're going to be talking about. And so we're going to define an angle to be something slightly different than what you might have seen before. All right? Consider a ray. So we have to be given a ray. The ray can be anywhere in the plane. I have mine going from upper left to lower right. That is not required. It can be any ray, anywhere, anywhen. And let's suppose this is the end point. Let's just call this end point, it doesn't really matter. Let's call the end point E. It is irrelevant the letter we pick to call it. So point E, the ray emanates from point E. And what we're going to do is this. We consider another ray. So imagine my piece of chalk here is infinitely long. It's another ray. And I have another ray with the same endpoint that emanates from E in the same direction. And I take this second ray, not this first one. This is the initial, if you want to use that word. This would be the initial. This is where it's going to end. So this is where it starts, this is where it ends. And what we do is we rotate. We rotate, keep the endpoint fixed, but rotate. Now I have a little ruler here. This might help you see what's happening here. And so what I have is, see, the ruler is the ray, and then we rotate. See how I'm rotating this? And so this rotates until we have, this is the side where it starts, and this is the side where it ends. They have official names. This is called the initial side, and this is called the terminal side. The side where it starts is the initial side. The side where it ends is the terminal side. Initial side, terminal side. And if we rotate, we all agree, this is the standard that we will always use. If you rotate, see how I have the little arrow, curved arrow here, arc this way? If you rotate in a counterclockwise direction, I know enough German to be able to know that's gegen den Uhrzeigersinn. That's gegen den Uhrzeigersinn. But it's counterclockwise. It rotates counterclockwise. This angle is considered positive. On the other hand, suppose this is the initial side, and now suppose we rotate clockwise. All right? That would look something like this. So here's the angle. So this is the initial side. Well, now we're going to rotate in a clockwise direction through however much we want to rotate. So that would be my angle. I'm going to draw it here. So this now is my angle. And now in this case, I have rotated clockwise. Clockwise is considered a negative measure. So counterclockwise, we measure that as positive. Clockwise, we measure as negative. And if this is my initial ray, so here I'm back to the initial ray. And the angle through which I rotate, I don't move at all. If the initial side and the terminal side are the same, then that is a zero angle. All right? In this case, this is the initial side, In this case, this is the terminal side. I'll write it down here. So initial side, terminal side. In this case, it's initial side, terminal side. And the extent of the rotation, there is no restriction at all. We are free, if this is the initial side, we are free to rotate as little or as much as we like. I rotated now. And so it might look like it's this. No, I started here. This is the initial side. And this is the terminal side. But I rotated counterclockwise. This is the angle I'm talking about. So this kind of way of arranging things gives us flexibility so that we can apply the ideas we have in circumstances like where a wheel is spinning, or an electronic disc is spinning, or gears are turning. And so this allows us to talk about rotating through larger angles than just small little angles that we might want to talk about. Now, we've already discussed this notion of measure, and so we will introduce the most basic measure of an angle that you're probably very familiar with. It's called a degree. All right? A degree. And what does that mean? Well, how much or how big is 1 degree? Well, there actually is a definition of what 1 degree is. If we have, think of this as being an entire circle, and if we have, let's pick anywhere we like. We can start. Let's start it doesn't matter where we start. Let's start it up here. So let's suppose this is the initial side. All right? If that is the initial side, then if we rotate, continue rotating, continue all the way around, so we do exactly 1 rotation, that is considered to be 360. The symbol for degrees is degrees. In this course, if you ever have a degree measure, if you have a number that is a degree measure, and if you do not have this symbol, you are not, I say again, you are not. You are not going to get full credit out of me. You will get a -1 because you did not label this with degrees. There's going to be 2 ways. Eventually, we're going to come up with a different way to measure angles. And if you do not have a symbol, we're assuming it's the second way to measure. And they're not the same thing. So, for the rest of this course, for anything we do in this course, if you have a number that corresponds to a degree measure, if you do not have the degree symbol, you will not get full credit for your work. All right? So, 360 degrees is 1 revolution. 1 complete revolution, exactly 1 revolution, corresponds to 360 degrees. An aside that has nothing to do with what we're going to do in our course, where that comes from, the reason 360 is chosen is because approximately the Earth takes 365 actually, but it's approximately 360 days to go around the sun. And so 1 degree is 1/360th approximately. So that's where this 360 comes from. But for us, that's neither here nor there. All we need to know is 1 revolution corresponds to 360 degrees. Or equivalently, 1 degree is 1/360th of a revolution. So if you only go 1/360th of a revolution, now we understand, we've seen protractors before, a 1 degree angle is tiny. It is a very small angle. In fact, it's much smaller than what I have indicated here. A 1 degree angle is extremely small. In fact, it's so small that the thickness of my little ruler here is insufficient to show it. And any picture I draw is almost certainly going to be not sufficient, because that's just not going to work. So 1 degree is a very small value, but it is 1/360th of a complete revolution. All right? With that, we then have special kinds of angles. Special kinds of angles, or names. I'll say categories. And I might as well start now on day one. You will write the word angle so often that you're going to wish you had an abbreviation. There is an abbreviation. It is this symbol. Anytime you see that symbol, that is the standard abbreviation for the or symbol for angle. And so we may say things like an acute angle, or we may talk about angle A. Or we may talk about, later on, we'll talk about something called angle BCD. There are certain names, but that symbol is always read angle. So we might as well go ahead and get that off the start so we can start abbreviating and shortening some of the terminology here that's so wordy. All right? So what are our names for categories of angles? All right. And these are in no particular order, but I'm going to go sort of in sequence here. We have a zero angle. What is the measure of a zero angle? Well, I think if there's any justice in the world, the measure of a zero angle ought to be 0 and degrees. And there is justice in the world, and the measure of a zero angle is 0 degrees. Notice it is not 0, it is 0 degrees. If you are asked for the measure of a zero angle, and if you write this, you are not going to get full credit. That's going to be -1 because you did not use the correct degree symbol. You're going to be using the degree symbol so much, you're going to start to sign your name Mike Evans degree or something. So you just use the degree symbol all over the place. Anytime you have label a degree measure, that number needs to have the degree symbol. All right? There's the zero angle. Then we can have an acute angle. An acute, it's here I've done already, an acute angle. And do we know the definition of an acute angle? Some might say this. Let's talk about, suppose I have an angle. Suppose that's my angle. I want to talk about the number. Now, you may, if you like, talk it as a variable. You may just label it with the variable x. That is certainly allowed, and that is more than sufficient. But usually, for now, usually, when we talk about angles, we use lowercase Greek letters. This is not set in concrete, but it is kind of set in asphalt. We use lowercase degree letters. The most common are lowercase alpha. Capital alpha looks like this, lowercase alpha looks like that. So on your Greek typewriter, don't hit shift. We use lowercase beta. Lowercase beta looks like a sort of a little b with an extra tail. Capital beta looks like this. Lowercase beta looks like that. And then very often we will use gamma. Gamma approximately looks like an alpha standing on its nose. Capital gamma looks like this. Lowercase gamma looks like that. Any other Greek letter can be used. The one that, even more than these three, the one that's by far and away the most common is theta. So this is theta. Capital theta looks like this, lowercase theta looks like that. So this is alpha, beta, gamma, and this is theta. So theta. So I'm going to label my angle theta. So theta is my variable that represents my angle, all right? And so an acute angle. So what we have for an acute angle we have 0 degrees is less than theta is less than 90 degrees. Notice my degree symbols. All right? Theta is assumed to be in degrees. When you write the variable, you don't need the degree symbol. When you write the variable, you don't need the degree symbol, but the numeric values we will. Now, some students would write this. Some students would say this. Some students would write this. This is not correct, because it is possible to come up with a value for theta that meets this requirement, and everyone knows it is not an acute angle, and it's very easy to do that. What if theta is equal to negative 90 degrees? So there's my initial side. Negative 90 degrees would be this. That's actually a square corner. This is not an acute angle. What if it's negative 100 degrees? Then it would be clear over here. That is clearly not an acute angle. And so an acute angle is not simply less than 90 degrees. It is between 0 degrees and 90 degrees. We are now going to, now for the rest of this discussion, we will assume that theta is non-negative, but for the record, there it is. All right, then we have a right angle. And we know what that is. An angle is a right angle if theta is equal to 90 degrees, not equal to 90. It's equal to 90 degrees. Let's get some space here. So maybe I want to draw some pictures here. So the 0 degree angle would be the angle lays on itself, right? An acute angle would be something like that. There's theta. A right angle would be, usually when I make a right angle, I will make a square corner, a little box in the corner to emphasize this is a right angle. For any other angle, I'll make a little curved arc with the arrow. Here, I will make the little box, the right angle. So here's theta. And then after a right angle, what is larger than a right angle is an obtuse, rounded at the free end, an obtuse angle. And an obtuse angle, don't simply say greater than 90. What you should say is 90. You should say this: 90 degrees is less than theta is less than 180 degrees. So if you simply say greater than 90 degrees, that would include things like 200, and that's not considered an obtuse angle for our purposes. So this would be if here's the initial side, and we have this. So this is between 90 and 180 degrees. There's theta. And so what we're talking about is as this terminal side rotates more and more and more around, we sweep through these various categories. And then let's see, what happens if this continues on? There's something we can call a straight angle. A straight angle, this is not very hard to figure out. Try that again. A straight angle is where theta equals 180 degrees. That is considered an angle. That's a straight angle. It has properties like other angles have. And I've run out of space here, so I'll move up here a little bit. And then we can have one other category. If we continue past 180 degrees, we generate what's called a reflex angle. Or reflex, if you prefer. A reflex angle. And that is if theta is greater than 180 degrees for our purposes. And so that would look like, if here's the initial side, we rotate around to something like maybe this. So anything for our purposes greater than 180 degrees is considered a reflex angle. Now, there's one extra little piece of the puzzle, and this is not a big deal yet, but this comes into play much more significantly later on. I'm going to erase this and talk about multiple revolution. Because if I start with my terminal side here, or initial side, and I rotate, if this is, maybe this is a pulley, or I'm sorry, it's there's a chain that comes around this wheel. This wheel is attached to some chain on a bicycle maybe. Well, you're allowed to have more than one complete revolution. You can have, let's try that again, multiple revolutions. So this is rotated and rotated, it continues to rotate, and it rotates and it continues to rotate. You can have multiple revolutions. And so we indicate that in this fashion, right? And so multiple revolutions. Now, we don't really state it. I mean, I suppose strictly speaking, a reflex angle is, you could say it's between 180 degrees and 360. But for our purposes, we won't bother with categorizing it in this fashion. But this is a multiple revolution. And you can have as many revolutions as you like to start. You may revolve 3 complete times. 1, 2, 3, and then finish it. So this might be our theta. So you may have as many multiple revolutions as you like. In all the work I've done here, I have assumed that we're rotating in a counterclockwise direction. That is not required, and we can consider all of these rotating in the clockwise direction, and all the measurements would be negative. But so we have different types of angles. We have the zero angle, the acute angles, the right angles, the obtuse angles, straight angles, and then reflex angles, and then we have multiple revolutions and what comes from that. So that's kind of a basic introduction to the working of angles. So what have we talked about so far? We've talked about the basic geometry, the lines, segments, rays, and from those we can create angles. If you rotate in a counterclockwise direction, that's a positive measure. If you rotate in a clockwise direction, that's a negative measure. And then angles, we have the various types of angles. So that's a basic start on some of the most ordinary terminology that we'll have for our working with trigonometry. A lot of this really so far is really just geometry with some numbers thrown onto it. But we'll get to the more detail later on. So this is the introduction to the various kinds of angles that we'll be dealing with as we go through our trigonometry course.